In the exam, I'm going to show you how to solve the inequality of a polynomial. This is a polynomial. I'm going to solve for x such that this polynomial is greater than 0. Here's solution. Step 1. Get a 0 on one side of inequality. Yes, I do have that. I have a 0 on one side of the inequality. If you don't have one, then you have to move them around. Then step 2, factor out if possible. So we factor polynomial. This is trinomial. So to factor out, I have two bundles. I have x here and x here. You have 2. 2 is a prime number. You have 2 and 1. And the invisible 1. Because it's a plus sign, this means I have same sign. It's a minus sign, means I have 2 minus sign here. Okay. 2 is also a prime number, which is 2 and 1. So I want to have 5 here, so I put 2 here and then 1 here. Let's check. 2x times x is 2x squared. Minus 1 times minus 2 is positive 2. For the middle term, takes 2x times minus 2 is minus 4x. Plus minus 1x from here is minus 5x. Bingo. Step 3, determine where the polynomial is 0. And to do that, all you have to do is take 2x minus 1 equal to 0. X minus 2 equal to 0. We solve for x. Right here I have 2. That means when x equal to 2, our polynomial here is 0. It's true because if x is 2, 2 minus 2 is 0. 0 times this guy is 0. Over here, I'm solve for x by plus 1 both sides. I have 2x equal to 1 divided by 2. So therefore, x equal to 1/2. This is another point where the polynomial equal to 0. Okay. Step 4, we graph the points where the polynomial equal to 0. Okay, 0. Somewhere around here is 1/2. Somewhere around here is 2. Let me do more further. 0, 1/2, and 2 somewhere around here. Now notice that these two values here divide our real number line into 3 regions. Now when x equal to 1/2 or 2, that means our polynomial is equal to 0. So in other words, if we go outside of this 2 point here, of a polynomial, the sign of a polynomial here will change. The inequality sign of the polynomial will be changed. Because remember, when x equals to 2 or 1/2, this polynomial is 0. So when I go outside here, I pick any point here, that will make our inequality, the sign here will change, either greater or less than 0. So our goal now is test to see where is the x value will make this polynomial is greater than 0. So to test it, I'm going to use this step 2 here to test the point. So I pick point x equal to 0. When x equal to 0, I have 2 times 0 minus 1, 0 minus 2, greater than 0. I have minus 1 because 2 times 0 is 0 minus 1 times minus 2, which is positive number. A minus times minus is a positive number, which is greater than 0. This is exactly what we want. We want some value that we make our polynomial is greater than 0. So our polynomial is greater than 0, so therefore it's true. This means our solution belongs from minus infinity to 1/2. Now let's test somewhere in the middle, so I'm going to pick 1. Let's put x equal to 1. I want to know when x equal to 1 is our polynomial greater than 0 or not. So 2 times 1 is 2 minus 1 times 1 minus 2. Is this greater than 0 or not? Have minus 1, I have positive 1 gives me times minus 1, which is a minus number, because a positive times a minus number is a minus number. Now, as I said, is minus number greater than 0? No, impossible. So therefore, our solution is not inside here. Now, test over here. I pick x equal to 3. So I have 3 times 2 is 6 minus 1. And 3 minus 2 have 5 times 1. Because I put a 3 inside here. So 2 times 3 is 6 minus 1. And then I have 3 minus 2, which is a positive number. Now, its positive number is greater than 0. Therefore, it's true. This means our solution belongs here. Okay. So now here is our answer. From here to here is our solution. So this interval here, say I have from minus infinity to 1/2. Then we also have from 2 to infinity. 2 into infinity. Our solution belongs inside here or inside here. We put a u, mean union. Now, x cannot equal to 1/2 or 2 because our polynomial is not equal to 0. Our polynomial is greater than 0, cannot equal sign. So therefore, we put the parenthesis here at 1/2 and at 2. So this is our answer.